Hey there, Year 12s. We're going to go through the Chapter 15 formative task here. Let's do question 1. You can have a look at the answers. I'll just quickly scroll through them so you can see 2. 3 is C. 4 is E. 5 is E. 6 is C. 7 is C. 8 is A, 9 is D, 10 is B. Okay, so let's have a look. Question 1. It says the capacity of the cut shown. So we've got a cut over here. I'm just going to highlight it in a different color. We've got this cut right here. And remember that the idea is you got to imagine it separating this source from the sink. So essentially, there is no water flowing from the source to get towards the sink. Okay, it's totally separated. And when they're separated, whichever edges that you've got touched, I guess, or highlighted, you can see this edge is cut through, this edge is cut through, this edge is cut through, and this edge is cut through. Then what you decide is which one of these that comes from the source. That's what you're interested in. So if it comes from the source, you then include that edge's capacity. So the capacity here is 11, capacity here is 4, capacity here is 6, and capacity here is 8. And then we look at the direction of each of those edges. And the direction, you can see it's coming from the source, and this point is coming from the source, and this point is coming from the source. So in fact, you would be collecting them all. So 8 plus 6 plus 4 plus 11. What does that give me? That's 6 plus 4 is 10. 10 plus 11 is 21. 21 plus 8 is 29. Okay, so that's how we get E as 29. Okay, next one. Let's see, the maximum flow from the source to the sink in the network on the right is, and we've chosen 10. And again, how do you find the max flow? It's through minimum cut. Okay, so you can do cuts like, and remember when you do a cut, the aim is just to separate the source from the sink. So it means that you can do any kind of cut. You can cut, and you choose the edges really. You can cut this edge with the 8, with the 7, with the 1. Ideally, you want to cut numbers that are small because remember, it's maximum flow. Max flow is minimum cut. So max flow, min cut. So you want to cut the ones that have the smallest value. So I might even do, so the one with the 8 and 7, you see 8 plus 7 already gives me 15. So I probably wouldn't do 8, 7, and 1. I might do 8 and 5 maybe. Usually those ones are possible. 9 and 3 maybe. So 8 and 5 gives you 13. And 9 and 3 gives you 12. Okay, but I can already see a 9 and a 1. 9 and a 1 right there. That cut there, that looks like it's giving me a 10. Okay, whilst if I did 10 and 1, you see that I'm cutting the edge of 10 and cutting the edge of 1. That gives me 11. So already, as soon as I see something smaller, see my aim is to get smaller numbers. I could do 10 and 3 if I wanted to. That separates the sink and the source. But from what I can see, you want to pair 1 with a smaller number. Now, I can't pair 1 with, I can pair 1, that's a small number. I can do 9 and 1, 10 and 1, but I can't do 8 and 1 because it cuts through that 7. So that's why my best option clearly has to be 9 and 1. And so those two edges, the question is, do they come from the source? And we can see source, yes, it comes out. We do have the 9 and we do have the 1. So that's your minimum cut. So my minimum cut right now must then be, I should do a dotted line to help you understand. So there we go. And therefore, 9 plus 1 gives me 10, which is minimum cut, which equals max flow. Okay, that's exercise 15A if you want to look at that again. All right, let's have a look at question 3. The capacity of the cut shown in the diagram on the right is 30. Wait, I just remember question 6 was a mistake. I remember they had an error in the solution. It should be B, actually. My bad for those who were a bit confused there. The answer should be B. Let's go back. The capacity of the cut shown in the diagram on the right is 30. Was that the one I'm up to? Yep. All right, so this is our cut. This is our cut. So the edges that we are interested in are this edge. So that's edge, that edge. What else does it cut through? It cuts that edge and it cuts that edge. All right, so the ones that we will include, anything that is from the source, so from this side onwards, so essentially anything on this side. So we'll look at the arrows, so 5 is definitely included, 9 will be included, B will be included, and 6 will be included. Okay, so they're all included. So they tell you that the capacity of the cut to the right is 30. Find the value of B. So that means 5 plus 9 plus B plus 6 has to equal to 30. Well, 9 plus 6 is 15. 15 plus 5 is already 20. So 20 plus B has to equal to 30. So you can see B has to obviously then be 10, or 30 minus 20 gives you 10. Okay, or if your algebra is not there, then we can say 20 plus something has to equal to 30, and we know the answer would then have to be 10. Okay, I'm just going to rub that green out because it doesn't look nice. B and B. Q. We're moving on to question 4, almost halfway. So now this looks like an allocation problem. 5 students, Anton, sports, hockey, yep. The bipartite graph on the right shows the students and the sports teams represented by the vertices. All right, which of the following statements is not true? Anton only joined one sports team. Well, that is true. Anton only is connected to hockey. So that is true. Twice as many students chose table tennis as chose baseball. So let's have a look at baseball. Baseball, we have 1. And that's about it. So 1. So, and what was the other one? Table tennis. Table tennis has 1 and 2. And that's about it. Yeah. So twice as many played table tennis. Chose table tennis over baseball. Correct. Baseball was only chosen by 1 student. Yes, it was Elliot. And then hockey was the most popular sport amongst the students. Is that so? So hockey, yes, hockey clearly has 3 here. 1, 2, 3. Whilst the other ones all have 1 and 2. And this is 1 and 2. The other one's 1, and this is 1 and 2. Yeah. So hockey is the most favorite sport. So by process of elimination, we can probably say E is correct. But let's just double check. Davina have chosen the same sports. Have they? 1. Davina, yes, they did choose table tennis, but Davina also chose badminton, so not entirely true or correct. All right, so that's why E was the correct answer. Okay, use the following question for 5 and 6. Ooh, this looks like a Hungarian algorithm. What do they do? Question 5, the table on the right, cost matrix above after the lowest value in each row. Okay, so remember the Hungarian algorithm. I'm going to write here. Hungarian algorithm, the first thing you do in the textbook they teach you is to subtract each row by the smallest value. So in this case here, in the row of Terry, you would subtract every one of them by 3. Here you subtract by 2. Here subtract by 2, and here by 3. Okay, so you can see that's why 3 minus 3 becomes 0. 2 minus 2 is 0. 0 here, and then 0 there. And that's what you'll see in this diagram, why they have 0, 0, 0, 0. Okay? And all the other terms have been taken away. So what they're trying to say here is the lowest value in each row has already been taken off. Which of the following steps should be completed next? So usually after you do the row, then you ensure that every column has a 0. Now this column in sports has a 0. This column has a 0. This column has a 0. So the only one that's missing a 0 is gossip. And then you subtract all of those terms there by the smallest value. Okay, so which is 3. So this would then subtract 3, subtract 3, subtract 3, subtract 3, which gives you a new total of 2, 5, 0, and 1. Okay, and so subtract all the smallest element. Yes, and that is correct. So that's what you can see there. That's essentially what we're doing, hence why it is E. And then what you do in Hungarian algorithm, if you've forgotten, this is exercise 15b. What you then double check is then, can you cover all the zeros? Okay, all the zeros. I'm just going to highlight where the zeros are. All the zeros as best you can. Okay, with the minimum number of, I guess, sports or allocations. And you can see here, there's 1, 2, 3, 4. If it was 3, then you'd be trying to do it in 3 lines. If there are 4 items here, 1, 2, 3, 4, then your aim is to cover all those zeros with only as minimal as you can. And if it's 4, then you're done in the algorithm. So I can see that I can do this. That's 1 line. That's the most efficient way to get rid of that. Maybe 2, 3, and 4. It looks like I can't really do it any other way. I can't do it in 3 lines. So that's it. My algorithm is done. So if my algorithm is done, when they say find the minimum time required, this is where I relate to both the tables. Okay, so where are my zeros at the moment? My zeros correspond with Nancy and travel. So Nancy and travel, Boris and travel, Nancy and gossip, and Jacinta and sports, and then Terry and politics. So those are my 3. So when I allocate them, you can see here I can allocate Terry only to politics, so T equals P. I can only allocate Jacinta to sports. Okay, and then Nancy has an option of gossip or travel, but if I allocate Nancy to travel, well then Boris can't do anything. So because of that, Nancy has to do gossip and Boris has to do travel. Okay, so Nancy is gossip and Boris is travel. So when you want to find the minimum time required, remember this here, they told you that it's allocated to one of the writers. So these are the writers and the overall time in hours. So you can see that Terry with politics will take 3 hours, whilst Jacinta will take 2 hours, Nancy with gossip is 5 hours, and then finally Boris with travel is 3 hours. So in total, you can see I am now doing 3 plus 2 plus 5 plus 3. So 3 plus 2 plus 5 plus 3. And this is where I changed the answer. It's not 14. It should be 13. So 3 plus 2 is 5. 5 plus 5 is 10. 10 plus 3 is 13. And that should be your minimum number of hours needed. Okay. And then moving on to question 7. So here we go. Question 7, the activity diagram on the right shows the activities required to complete a particular project and their durations in weeks. Okay, so they've already got the critical path for which project is shown with a solid line. So this is my critical path already. if the project takes 22 weeks to complete, the duration of activity D weeks is, I got the answer in 8. So if the project takes 22 weeks to complete, the duration of activity D, so essentially we know that the critical path tells you the minimum time required. So you got 5 plus D plus 5 plus 4. So that's what I'm doing. 4, 5, D, and 5. And they're meant to total 22 weeks. And so you can see 5 plus 5 is 10. 10 plus 4 is 14. So 14 plus D has to equal to 22. So 14 plus something has to equal to 22. And we know that must be 8. Okay. So that's how we got 8 as our answer. Next one, question 8. The activity network that represents the information in the precedence table on the right is, okay, so on the right, A and B has no predecessors. So I'd be drawing something like this. So A and B. I usually look at the end as well. So E is my final activity and it has precedence C and D. So I'm thinking C and D, and then I try to work out the center. So C has precedence A and B, so that means this A connects with the C. Okay, so in my mind, they will connect, and then notice that it's also precedence of B. So one of them has to be a dummy line, so you can think of it as, it'll look like this. This is C, and there has to be a dummy line. And remember, when you're doing dummy lines, you should write dummy. Okay, technically you should be dummy, comma B, so people know that it's coming from B as well. But you know, you can write dummy with the arrow, and that's sufficient as well. And then notice D comes from A. Oh, that's interesting. So D comes from A, has a precedence of A. So yeah, I probably would have to reorganize this because then you'd have two dummies connecting, so that doesn't work. And so I'd probably, since D comes from A and I needed B to connect with C as well, then the best way to do it is like that, D, C, and then do a dummy line that connects A to C. So that way, C, A, and B are all precedence, and D only has A. Don't forget to write the dummy. And, but then C and D has to connect with E. So it means I just make it an angle then. So here we go. So E, like that. That's E. So this is E. And then this will be D, and then will be C. Something like that. There you go. And yeah, there you go. That's A. So that's how I usually do it. I usually work with the start and the end, and then I try to figure out what the center should be. But you can see it takes a couple of iterations. So maybe do it in pencil is probably a good idea. Or I guess in this case, they already had the diagrams. It's probably quicker to look at which ones make sense and which ones don't. For example, this one clearly is saying that E has a precedence of D, which is true. It has precedence of C, but hey, this all works. So the only thing that this is missing is it doesn't have a precedence of A. Yeah, so that one doesn't fit. Oh, yeah, maybe it's best just to look at the graphs rather than draw it in a multiple choice section. Question 9, let's see, for the activity network shown on the right, the earliest time in days that activity F can begin. All right, well, earliest time. So usually to do these things, I usually find the critical path first. Yeah, I'm going to find the critical path. So how do you find the critical path? Use the Dijkstra's algorithm, but find the longest pathway. So out of this point here, I can see that that will get me 9. Okay, and that's the only way to get to 9, really. This one's 7. 9 plus the 7 will give me, what, 9 plus 7 is 16. 16 plus 8 gives me this point 24, isn't it? Whilst 9 plus 5 gives me 14, but that's not what I want. So, as in, it's the smaller value. So, I can see then 24 is the value for that point. 16, there's no other way. 7, there's no other way. 9 is the best. And then from 24 plus the 5 gives me 29, and then 29 plus the 6. So this is all pretty standard here. So 35. And then to work out your earliest start time, it was probably easier if I just went directly there, shouldn't it be? That's all right. So usually I would find the critical path. So it looks like this. Okay. And then based on that, I can already see why it's 24. But so because this path here is on the critical path, you see, technically there is no, the earliest and the latest start time has to be the same. And so that's why it has to be 24. So float time is 0 there. But I can see a lot of people doing 9 plus the 5 and saying that the earliest start time they can do is 9 plus 5, which is 14, which is wrong. Because the reason why is because F has a precedence of E. So F can't start until E and C are complete. But you can already see that D has to finish before E does. So E will take a total of 7 plus 8, which is 15 on top of the 9. So 15, that's why it's 24. So you can't say it's 14 because if you say 14, E hasn't complete. That means F can't start anyway. So that's why you'd still have to wait a total of 24. That's the earliest start time that F can then begin. Okay, so that's the logic. So usually your critical pathway will indicate that. So that's question 9. And then question 10, same idea. Find the critical path. So again, I would be doing, here is 3, here is 5, but 3 plus the 6 gives me 9. So 9's a better value. So that's why I rub out the 5 and say 9 is the higher value. 3 plus the 6 up here gives me 9 up here. But remember, I could have gone from 9 and go all the way up. Plus 7, so 9 plus 7 gives me 16. So therefore, 16 is the minimum time required at that point. Over here, 9 plus the 5 gives me 14. 9 plus the 7 again gives me 16. But remember, 16 plus the 7 this way gives me a total of 23. So 23 is the best there. 14 plus 8 gives me 22. So 23 is still the better value. And then 23 plus the 1 is 24. So that tells me the only numbers I really needed. Oh, wait. 9 plus 7. No. So it was this way and then that way. Okay, so you can see 3 plus 6 is 9, 9 plus 7 is 16, 16 plus 7 is 23, and then 23 plus the 1 is 24. So that is my critical path. So there we go. Here's my critical path. Okay, so the edges I've just highlighted were A, C, E, H, and J. And there you go. That's why it's B. Okay, so this section here is just to show you how to do the multiple choice questions. Hopefully that helps clarify some of the things that you've learned in chapter 15. In the next video, I will do the short answer questions.